Welcome, welcome, welcome. Once again, I'm back on the coding streak. Gonna continue up with last week, or I guess on Friday's coding, where I cleaned up some of the HTTP client handling, and now I'll be handling some parallelization. Well, at least trying to, because parallelization is always kind of a tricky thing, and generally is things you iterate on quite a bit. It's not something you can get down on the first try. So that's what I'm going to be doing today. I'm going to try to parallelize the Streamerverse project, try to make it so that I've got like, let's say 10 channels running for the 100 streamers. So 10 channels for 10 streamers, and this will run maybe every day, let's say, or every 3 hours. Because something that I want to, I should explain is, if I were to fetch the streamers, the top 100 streamers at any given moment of a day, I might get a completely different set of top 100 streamers. Because if I fetch it early in the morning, my time at least, early in the morning my time, I may be getting some European or Asian streamers, or even some Hispanic, or maybe some South American streamers, where if I do it more midday my time or evening time, I'll get more of the North American crowd, more of the Western Europe crowd. And then again, if I go later at night, once again I'm going back towards the Europe or some of the Asian crowd. So depending on when I fetch the top 100 streamers, I may be getting a bias towards a different set of streamers. So that's why I think it's important that I can't just fetch it once a day. And if I do fetch it once a day, it has to be every day it's at a different time, so that it accounts for that bias. Because if I just do it at the same time every single day, I'm going to get a really biased snapshot of just the North American crowd, or maybe just the Europe crowd. Or maybe just that halfway point before the American crowd comes on and the Europe crowd is starting to go out. Like, it's really hard to just do this once a day. So you really have to do this at least twice a day, maybe once in the morning, once in the evening, preferably multiple times a day actually, so you get a really good snapshot. Because some people may not stream for more than an hour a day, like VTubers, for instance. I get this shit all the time on my goddamn recommended on YouTube. VTubers stream usually, I think, an hour, 2 hours. That's usually the time frame of stream is a 2-hour stream. And if I were to maybe only do this twice a day, so 12 hours apart, I would generally miss a lot of these streamers. And I can't, and obviously I want to make this as fair and as accurate as possible, so I have to be fetching this data multiple times a day at different subsections at intervals that account for the least margin of error. So to do that, I have to fetch this data 3 times a day. And that's going to be annoying, because one, that introduces a lot more data to process and a lot more data to store, and 2, it sucks to have to code. So that is kind of where I'm at with the parallelization, and that is something I've thought through quite a bit, and I think I've got a good idea of what I want to do. I think 3 hours every day, so at 3-hour intervals, get the top 100 streamers, parse them, store the data, and then wait another 3 hours, then do the same thing again. Keep doing that for an entire week, and then once I have a week's worth of data, compress that into one snapshot, store that in the live database, and then serve that data to the public. So that means people will have a granularity, so they can change it from on a week's granularity. So if you want just a snapshot view of 1 week of the stream, top 100 streams, 2 weeks, 3 weeks, a month, that's possible. But you couldn't go less than a week. You couldn't do days, you couldn't do hours, because at that point it's just ridiculous. And I think that the benefit of having that is almost nothing. So I'm not going to allow being able to filter down to a day. I think a week is fair. So with that in mind, let me switch over to the display, capture display, and let's see, just run this, see where we're at, make sure it's all good from Friday. That's compiling. Okay, yeah. I was wondering what was going on. It's compiling. And there we go. So right now, Aiden Ross and XQC are the top 2 streamers, and they are sharing 142 chatters. French Canadian. That's kind of apt for XQC. It's kind of funny. So, all right. So that's good. Everything's looking good. But now I want to make it so that these two calls are done in sequence with each other in different thread or threads for other languages, channels for Golang. So if you don't know much about Golang, quick snap or coding maybe generally, there is a concept for asynchronization called threads, or even processes, another word, or if you're specifically in Go, channels. And you might hear me use these words interchangeably because they're almost essentially all the same. There is a bit of a difference. There is some unique differences. For example, a process could refer to a singular process on a CPU, so a single process chip on the CPU, which is a lot more beefier than a thread on the CPU. So the thread is essentially just a stream where work can be done on the CPU, where a process is in a physical thread allocated for that program. Whereas a channel is a Go-specific implementation, which is hyper-optimized and really useful, where it takes out a lot of that unnecessary low-end knowledge that you need to have and just gives you the raw functionality that you need. If you didn't understand what I just said right there, don't worry about it. You can, if you care, watch what I'm doing as I'm going along. And if you're confused, if somebody's watching this and they're confused, feel free to leave a comment. Like, I don't mind helping people out with this sort of thing. I found out that a lot of people watch my videos, a lot of people watch my Golang videos, and it seems like the reason why is because they're trying to learn Golang, and my videos for some reason were recommended. So if you are watching this because you're trying to figure out something with Golang, feel free to leave a comment, and I'll try to respond to you if I can help you out, because like, I don't mind helping people out with programming. That's kind of why I'm trying to do this kind of half split of gaming and programming, because I do have the software development background, so I do know a bit about programming, and I don't mind sharing that knowledge with people. I actually kind of enjoy teaching people. But I also don't want that to be my sole focus of my entire streams. I don't want to just program. I want to do gaming content, and I want to program. So if you don't like the gaming content, then fine, that's completely your choice. Just watch the streaming stuff or the coding stuff. If you don't want any of my coding stuff, watch the gaming stuff. That's kind of how I see my channel. But okay, I'm getting off topic. I'm just kind of going down a rabbit hole now. All right, so first up is, how do I want to structure this? So first off, to do a channel in Go, the simplest way is just to call Go like that, and then whatever you want to do. So for example, if I wanted to parallelize these two get chatters requests down here, I would go twitch.getchatters tstreamer. As you can see right there, this, and then I guess I would duplicate this call, but instead of using tstreamers, I'd use fstreamer. And then I could comment this out like such, and it would do the requests. But actually, I'll keep this in. But as you can see here, it doesn't return the chatters. Like, this is done in a background process. So this foreground main will have no reference to whatever this returns. It'll basically be swallowed or lost, which isn't what we want. We want to keep that data around. We want to know, we want this to be returned back up to the main process, the foreground process. To do that, you either can use a concept called channels. Chan, kind of funny how that's called, using a channel, and then like an array of t chatters. Or how the hell does it go again? I think it's t chatters and an array of strings, something like that. Or is it like this? Okay, that's how it's done. So it's a channel. So this way you can pass this channel down into this process, and then the process would write into the channel, and then the data, whatever data this process wrote into that channel, would be accessible by this main process up here, in the foreground process of main. which is helpful in very complicated situations, or there's a lot of situations where this is useful, and I might actually have to use this later when I'm setting up a queue system for pushing the streamers to each of the individual workers that I'll have set up for this. But for now, just to kind of show off show off the parallelization stuff. What I want to do is actually, before calling tchatters or before calling this as background processes, let's go ahead and create the two chatter variables. So it'll store the it'll store the two separate chatters as, turn off my insert. Jesus, I'm having a tough time typing. Like that. And then instead of calling the get chatters directly as a background process, we will use some functional programming and define a function that inside of the function, all it does is call our get chatters like this. But again, it's not, as you can see here, it still doesn't return it still doesn't return the chatters, or the error for that matter. And I realized I have the wrong type here. String bool. It still doesn't return the get chatters up to the main process. It's still down here, as you can see, in this lower level process, and these two variables will always remain empty. So what we do is we actually use some scoping tricks that Go allows, where we basically declared them as a higher scoped variable, or a higher scoped high scoped variable, or a global variable if you're more familiar with that terminology. What do I want to do? And then I can, so you can panic in here. That's completely fine. So as you can see here, oh no, so okay, so I actually can't do this. I just realized is because this, if I were to do it in this definition like this, it'll assume, because this syntax creates and then stores whatever is on the right. So it stores whatever is returned on the right into the two newly created variables on the left. But this isn't new. I already have this defined up here. So what I have to do is take that out. As you can see here, it's storing it up. It's using the variables from up here. So like if I highlight this, you can see it's highlighting the errors up here. If I highlight this, it's highlighting that. So you can see here they're linked. So it's essentially a global variable on a process down here. Similarly down here, we take that out, and it'll do the same thing. The one issue is that the error is shared between these two. So if for some reason this were to put in an error, it might panic down here, which is obviously something we don't want. We don't want the errors between these two function calls or these two background processes to be shared. We would prefer them to be unique to the error of the scope or of the process. So there you go. Now it's green. So if I were to highlight this, they're not shared. If I highlight this, they're not shared. You can it's helpful with Golang because they give you this coloring to distinguish what's different scopes. So if I were to run this, and you can see down here, this is no longer a problem. And you can see down here, this tchatters comes from this definition here, which will be populated by this call here, and then will be used down here. But there's another problem that has to be addressed before I can run this, and that's, since these are background processes, they don't block. So like so as soon as I call this, it'll continue on to call this, and then it'll call this immediately. But this hasn't finished running yet. It could still be populating the data, or still could be fetching the data. So we don't want to call this until both of these are finished. So these will both run in parallel to each other, but we still don't want it to pass this point here. Like, we don't want it to go past here until we've gotten the data from both of these. So there's loads of different ways you can handle this. You could use a channel again, actually, if you wanted to. But for the most part, a lot of people use what's called a wait group, which it's a Golang thing, wait group, which essentially, I won't get into too detailed, is kind of like a locking mechanism. If you know anything about atomic processes or atomic variables, or anything, just kind of the atomic nature in programming. You kind of know what this is, but for now I'm not going to go too far into it. So as you can see here, there's three functions that you can call on the wait group. There's add, done, and wait. Add, all that does is tell you how many processes there are that you have to wait to finish. Done is called by the background process to signify, hey, I'm done, I've returned, you can continue on now. There's no need to wait for me anymore. And then wait is essentially that. It'll just wait. So what happens is, if you want to think about it, we add two variables or two numbers. Let's say we have we have a pile, we have a bucket and some sticks. We add 2 sticks to the wait group bucket, and when we call done, it removes 1 stick from the bucket. When we call done again, it removes the 2nd stick from the bucket, and then once the bucket's empty again, this will release, and we can continue on with the rest of the code. So long as both of these dones haven't been executed, this command right here will block. So we won't progress down here to that gibberish that I just put there until both dones have been called. Hopefully you can understand that, but it's a nice way of preventing code. It's a nice way of adding blocking code for an asynchronous area. So we want it to be asynchronous right here, but then become synchronous again right here. So we basically think of it as one stream splitting into 2 streams. So up to here, we're at 1 stream. We split into 2 streams, and then we merge back into a single stream to continue on with the rest of the program. If you kind of can't really understand that, put both of your hands together, put them against your chest, and then move them forward. And then at this point, we move your hands apart. So we split them apart into 2 hands distance apart, move them forward, and then when we call wait again, we put our hands together again, and we're now synchronous again. That's kind of how it would work. And now with that all out of the way, we should have parallelized these 2 calls. Obviously, this isn't the completion of the parallelization. There's a lot more that needs to be done, but this is just generally how you'd parallelize some code in Golang. This isn't the preferred way that I'm going to keep it as, but this is just to show off parallelization. And I guess I can I'll just run this and you'll see it. So let's bring this back. I'll bring this back, and then I'll comment this out. I'll comment this out, and then I'll show you just kind of a time difference. So I'll start time.now. So this is our start time. I'll actually get down here. Let's go down here, and then we'll add it to right here. Start. And then format.printf, or print line, I guess. Time our start sub, or actually no, time dot now sub start. So we'll subtract the start time from the current time whenever this ends to kind of show how long it took for this function call, this and then these two functions to execute. So you can see there it took 318 milliseconds for this to run. Now let me do the parallelization. I imagine it won't be that much faster because again it's only two calls. That's like nothing in terms of performance. But like imagine whatever I save here, but on an exponential scale of like 100, or if I increase this to like 1,000 streamers, or 100 streams every 3 hours, like the performance you save there is substantial in my mind. So what am I doing again? Right, I'm commenting this out. So remember this number, 320 milliseconds. Make sure this is all correct. Yep, so 320 milliseconds, and if we run it like this, 200 milliseconds. We saved 120 milliseconds just on those two calls. Now 120, multiply that by, again, by let's say 100 streams, you're saving you're not saving exactly 120,000 milliseconds. That's not true. There's a bit of variance there, and obviously technicalities reasons that's not true. But you can understand just by parallelizing this, we saved 120 milliseconds, and when we scale the program up, this will save us a lot of time when it comes to running the program. And in my mind, or not in my mind, but in other areas, this will also save on resources such as memory, CPU bandwidth, and just overall cleanliness of the code. So as you can see here, as you can see by that, that's enormously better than this. So we'll get rid of that. I'm going to get rid of this too because I made my point already, so it's not necessary to show that anymore. And next steps are moving this into a way where I can push it down to multiple workers. So in a program such as this, there is a what's it called? A common style that you use, a common kind of like layout format that you would for this kind of like work related programs, where you'd batch the work into jobs, and then you'd give a job to a worker. The worker would do that, and you'd have multiple workers at once, and then you'd have managers. So I'm not going to open up Paint, but if you can think about, I'll open up Paint. Fuck it. Open up Paint and I'll show off my shitty Paint skills. Think about it like this is the manager. The manager has 3 workers. Okay, that was terrible. Actually, let's just do this. 3 workers, Control C, Control V, V, select. How do I do this? I completely forgot how to use Paint. That, select that, Control C, Control V, Control V. There we go, 3 workers. So this is the manager. God, that was awful. This is the worker. These are the workers. And then underneath each of the workers, there is a job or multiple jobs. And ta-da! That's how generally a parallelization of this kind of program or this kind of problem would be solved. You'd have the manager, who would be kind of in this essence the main program, delegating work to each of the workers, and then each of the workers would then go through each of their jobs sequentially, and then once all this is done, the manager might give the workers more jobs, or it'll just sleep, which in my case it will. It'll sleep for 3 hours and then give all the workers the same amount of jobs all over again. And that's how I'm planning to parallelize this. And my biggest concern, well, not concern, but annoyance, is just programming this out is usually annoying, and it's a lot of trial and error, and you can run into things where you might leak resources. I mentioned this before, where if you're not careful with how you allocate things on with like the response, like decoding JSON responses, this data, if you don't close it, or I guess for example the file, when I open up this file, it stays in memory permanently until I close it. So if I'm not careful, same thing can happen with the workers. I leave a worker running, or a worker accesses some memory that it doesn't let go of. I can just leak resources. In some case, it could just keep eating up resources, and I get what's known as a stack overflow. And that's annoying to encounter. So hopefully I handle this properly and I don't encounter one of those. But for now, let's go ahead and start thinking up how I want to organize this in terms of like the project layout. I think the best way to do this is just to have this in the main, and then later on move it into its own packages once I've kind of figured out how I want it to be structured. Because that seems like a good idea, because don't worry too much about the structure now, worry more about just the implementation, and then clean it up later. That's generally, if you do any coding interviews, that's what you do too. Just get a solution out there, and then think about how you can make it better after. I'm drinking a can of Coke right now too. Okay. So, in this example, or in this project, the jobs are essentially the streamers, or the streams. Each stream is technically a job, and we want each worker to handle only 10 jobs at a time. Because if they handle more than 10, that can get annoying. Or maybe not tell each stream, or maybe not tell each worker that they can only have up to 10. Maybe just make only 10 workers. And if one worker is faster than another worker, hey, that's great. But don't over allocate, or don't overcomplicate the problem, I think is what I'm going to try to go for here. Yeah, because if I try to like make it so that each worker only takes the 10 jobs and has to get from this list of jobs, that might overcomplicate it. I might as well just make it so that... Okay, so for now, let's go ahead and change this to a for loop. Not just, nope, don't do it like that. X equals 0, x less than or equal to 10, x plus plus. So we loop through an array of 10. We add a delta of 1. So as you can see here, back to my stick example, it'll add 1 stick to the bucket 10 times, so it'll add 10 sticks. In our case, it'll add 10 workers, and I will define a function called worker, actually, that takes the weight group and not the streamers, because I'm going to define that in another unique way, but does it return anything? No, I'll have it panic. No, I won't have it panic here. I'll have it panic outside. No. I'll have it panic in here. I'll have it, if it does panic, I'll have it panic inside. Start off wait group dot defer done. Defer, quick recap, just means that whenever this function closes or ends or exits for whatever reason, this will be run. Regardless of the outcome of the function, it will always run this at the very end of the function. And so then a worker will do something of this sort, where it will get the chatters from the streamer, which in our case will be, here I'm going to introduce you to the channels, streams, which is equal to a make of a channel of make channel of, this is strings, right? Of twitch.stream. Ooh, that might be annoying because that's not exported, is it? No, it's not. Oh, I guess I'll export it then. Oh no, what did I just do there? Don't do that. Stream, Twitch stream, a channel of Twitch streams of size 100. So you can do it with or without this. It's called buffered/unbuffered. So I believe this is the unbuffered version. Okay, I don't want to be wrong about this, so I'm just going to quickly Golang buffered channels. Okay, so no, this, okay, yeah, that makes more sense actually now that I think about it. This is a buffered channel. Buffered channels are basically channels that have a fixed size. So you know exactly how much data you're going to put into them and how much data you're going to receive from it, and nothing more, nothing less. And this makes it a bit more efficient. But if you don't know at runtime, or you don't know ahead of time, and at runtime you just want to size it dynamically so it'll get bigger or smaller based on what's put into it, you can just make it unbuffered like this. Problem is one of these is a channel like an unbuffered. Jesus Christ! I just had a seizure or something. God, sorry, my speech pattern just broke there. If you have an unbuffered channel like this, then you might you'll encounter things known as read and write locks or read and write blocks, where if you try to read before or try to write before there's a reader attached to an unbuffered channel, it'll block the call, which can get annoying. If you care, just Google Golang buffered/unbuffered channels, and it'll go through there's a bunch of resources online for this sort of thing. So don't worry about getting lost if you're concerned about that sort of thing. Oh, the main theme kicked in. If you couldn't tell, I was listening to the Skyrim soundtrack. Hopefully I don't get copyright striked by UMG. Fucking assholes. Still no update on that dispute from them. I'll win this eventually. Let's see. Okay, so does this work? No, that wouldn't work. I didn't think it would. So what I have to do now is actually let's just rename this to jobs. Nope, don't reformat all of that. Just that. Let's rename that to jobs. So right now, I can't just copy the return from this into this, because it's technically two different types. What I have to do is actually write all the jobs, or all the streams, streams into jobs. So, like this. Ta-da! Or oh, there you go. So it's a channel of 100 Twitch streams. So there you go. Wait, I wonder if I can do this actually. Now I think about it. Maybe I was stupid. Maybe you can just write it in. Oh my god, you can. Can you? No, you can't. Yeah, I am smart, but I'm also stupid, as you can see. I was right and wrong at the same time. Alright, so there you go. So after we get all the streams, We range through them, write them into the jobs, which 100 streams, that's quick. If you want it to be cool, you could maybe have it in here, return like a channel stream. I don't know. It's kind of ridiculous, honestly. And if you really wanted to, like, I don't know why you do this, but you could paralyze the rights. You could do that, but that's ridiculous. That is just way too. That's dumb. Don't do that. Don't try to paralyze the rights into this. That's just so much finessing that doesn't need to be finessed. Alright, so we've got all of our jobs put in. So this channel's been filled up completely. But now we want all of our workers to then take... We want all of the workers to then take their jobs, chatter, or stream. So we then pull from jobs. Can I do it like this? Okay, don't actually do what I'm about to do here. Do as I say, not as I do. I'm gonna be... This is... Okay. That is... You can do that, but it's very ugly, as you can see what I just did there. So, I'll explain what I did. Don't do this. This is not something I'll keep. Basically what I do is I'm reading. This right here, it says read from jobs. So, this arrow indicates pull out of jobs, if you want to think of it. This means put this syntax or symbol, if you will, means push the thing on the right into the thing on the left. So push S into jobs. And this over here means pull thing out of jobs into nothing. Literally just pull it out, inline it, and then get the username of whatever we just pulled out. Another way of doing this, and the better way of doing this actually, is streamer. Jesus, come on. And then streamer. Like that. So I pull the jobs out. I pull a job out of jobs and assign it to as streamer, and then I call streamer.username. So this will only execute once. So this would only get the top 10. So this would make 10 workers, and then each worker would only get one streamer. That's not what we want, but I'll leave it as that for now. I wonder if actually there's a better way to pull from a channel. Nah, that seems like the way. Chatters. So we have to return chatters for comparison. I'm wondering how I want to do that. I could store it somewhere and then store it somewhere globally accessible and then do like the comparison of streamers amongst everything. What do I want to do? How do I want to store the compared value of chatters? I could just return it. I could just do this. God damn it. I could just return it directly like that. Sorry. Like that. Oh, come on. Like that. But again, the thing is, this doesn't take anything. Like, anything I return here is just lost to the void forever. So what I'm thinking is, Let me just check something real quick. Is append thread safe? Oh, Jesus. Is Golang append thread safe? Not always. Doesn't look like it. Okay. Append is not thread safe. So what I was thinking of doing is just making like an array and then appending all the returns into that array. But since it's not thread safe, I can't pass it down into what is known as the thread or the channel, because it could just miss data, or I could just completely throw data aside, which is not what I want to do. For now, I'll do it like the way I just thought. I'll make a global streamer to chatter, make map string to a map of strings. Is it a map of it's a map of strings. Chatters is a map of strings. That's because I wanted to quickly compare them. It says check shared. Which is also, it's bool, like that. So then what happens is I'm not going to return it because I don't think that'll be wise, or maybe not wise, but it'll be annoying. Let's go, and then after that we go streamer to chatter at streamer dot username name. Come on, username equals chatters. So there you go. So now we're I know this is thread safe. I know accessing an array or adding to array, because I know this streamer will never have existed anywhere else, because this is thread safe. Reading from a channel, writing to a channel is thread safe, and so that means no other worker will share the same streamer, and so that means this will have never existed in this array before, and we can easily insert it into the array without worrying about any other worker possibly conflicting. And then we can remove these, and then we go streamer to chatter. What are their names again? XQC. Oop. XQC. Streamer to chatter. Sykkuno. We'll compare Sykkuno and XQC. That should work. This is assuming Sykkuno and XQC are in the top 10. Because remember, this is only fetching the first top 10. So we only made 10 workers. And each worker only fetches one streamer, which isn't what we're going to have in the end game. Or I'll just do this now. Why am I trying to prolong this or delay this? I'll just do this right now. An infinite loop. So this will loop infinitely until reading from empty channel. What happens if I read? Channel closed. Check if channel is empty. So it looks like I should make it a default select. Okay. No, I know I can do what I thought I was gonna do. Okay. Actually, I was gonna do it like this, and it looks like that just corroborated what I thought. I was worried that that wasn't a valid way of doing it, but I think I was just being stupid, silly. Oh, did I close that? Oh, I closed that tab. Hold on, let me open that again. Okay, it's just range like that. And then this will range through every single job in the streamer so long as there's a job available. And then once this is done, we close the channel, which is streams. Right? No, jobs. There. Ta-da! There we go. And this way, we will go through all the top 100 streamers in an asynchronous way. Let's go ahead and run this. Hopefully, I don't panic anywhere. I did. Wow. Bad request. Add a bit in from here. Let's go format.arf. Just so, come on. Just so we can get a better understanding of who's causing the problem. Username. Strings to lower. Just so it's similar, it's the exact same. Now we'll know who's causing the panic. You're causing the panic. I wonder if they're the same. I can't read Chinese, but it looks the same. Well, the characters look the same. I'm wondering if this isn't. I'm wondering if that's not a valid way of calling this. What's the chat room URL again? Come on. Where are my buttons? There they are. Slash user, so you slash chatters. That doesn't work. But if I were to go XQCOW, that works. Who are you? Who are you? Who are you? Twitch.tv slash. That doesn't work. Okay. Get chatters. It's print line streamer. I'll just remove this because it's unnecessary at this point. I know what will happen. Okay, that doesn't help because the names aren't there, so I don't know what the object looks like. What does the object look like? Fuck. What is a streamer? Okay, so this is their ID. This is their user ID. This is their user login. Oh, I wonder. Will their user login work? It does. Oh, okay. Now we're getting somewhere. I have a Netflix ad. Enjoy a free Netflix ad. My name is Chimchak. Don't panic, stay calm. Okay, hey. I'm all for that. How long is that Netflix ad? I got stuck with like a 40-minute Netflix ad. Fuck Netflix. Alright, let's see. How... I wonder. But what about XQCs? Okay, actually, hold on. This might be... This may be interesting. So, Zillanier worked. And that works for getting his chatters too. Okay, so Zillanier, so using the what was that? The user login works, but I'm wondering if it works for everybody. Because if it works for everybody, then I'll just use the user login. But if it doesn't work for the everybody and it only works on some people, I'll just try that. I'll just try using the user login and see if there's any more panics or any more problems that come up. If there aren't any, streamer to chatter, streamer, user login, user login. I don't want that to be different if that is the case. I maybe want to put in logging into this so I know for a fact if it's doing something or not. Because right now, I have no idea what's going on. I don't know if it's stuck somewhere. I don't know if it's still doing work. I have a weird feeling that it might be stuck somewhere right now. I wouldn't know where. Alright, yeah, I'm gonna add logging, because I don't know what's going on. Num streamer user login. Hopefully I don't get rate limited here, because this is where I could definitely start to get rate limited. Oh, fuck. Forgot to add the formatting for lowercase, or for new line. Then it just stops. Why does it just stop like that? Finish processing. Okay, it's not exiting. I think I was lied to. I think whoever wrote this is a goddamn liar. Golang. Check channel empty. I'm gonna check something else. I don't know if that'll actually work, but hey, it's worth giving it a shot, and don't forget that. Yep, 0 jobs remaining. It does work. Okay, if that's true, then that's the case. Then if length of jobs 0 break. Let's go streamer jobs. I could do it like this. Yeah, I don't care. Did that not work properly? Did I do something wrong? There's like Captain Puffy. Who the fuck is Captain Puffy, and why am I comparing him? Wait, is Captain Puffy's goddamn? Hold on. XQC isn't in here. Huh? Did he go? Is he done for the day? Oh, he's done. Oh, he's done. Oh shit. Okay, that's why. Whoops. Let's go Captain Puffy and Sykkuno. Let's see. There we go. Look how fast that was, too. It went through 100 streamers in a second, if not less. And that's only with 10 workers. I could bump this up for sure and make this faster, but at that point, it's unnecessary. There's 270. And it looks like using the user login is the right way to go. Like, it doesn't seem like any specific person is missed by doing it that way. It makes sense, I guess, why that. Now I kind of understand why there's the difference between user login and username. I imagine Twitch's backend system, one is based off the Justin TV, is really old and probably doesn't account for like those weird Chinese HTML characters. And so the login requires plain ASCII characters, like the regular ASCII from the ASCII table. So only characters that fall within this range here, from capital A, or I imagine there's some exclusion, but like probably from 65 down to 90, and from 97 down to 120. And then maybe some others from like the other characters, like exclamation, that sort of stuff. But they don't accept like the extended ASCII codes or like even the HTML codes. Okay, so that's good. Looks like I'm getting all the streamers, or I'll keep that up actually. Oh, I already had that open. Keep that up. And the one annoying thing about doing it this way, where I store it in as a string denoted by the streamer, is I don't know who's number one, number two is. I just know that these two exist and the top 100 streamers, but I don't know which one's number one, number two, because usually I like to compare number one and number two just to see. I could just print it, I guess. I could print out who's number one and who's number two. So I have this. I could easily do that. Whatever. Okay, so this is done, but obviously I don't want to keep this in main, and I also have to, I'm doing all this parsing, but I'm only comparing two people. What really needs to happen is I need to compare Sykkuno to everybody else on this list, and then I have to compare Captain Puffy to everybody except for Sykkuno, because they've already been compared. And I have to do this through 100 people, so that's basically 100 multiplied by 99 multiplied by 98 multiplied by 97, so it's 100 factorial. So 100 factorial, which means that many comparisons. That's annoying to do. I think so, at least. 100. Is that? I'm right? Factorial. Yeah, it's okay. I was right. Factorial is n multiplied by n minus 1 all the way down to 1. Yeah, okay. So I have to compare Sykkuno to 99 people, because there's 100. Sykkuno is one of the 100, so I don't compare him to himself. Then I have to compare Captain Puffy, assuming he's number 2, to 98 people, because I've already compared him to Sykkuno, and I don't compare him to himself, so 98 people, and then yada yada yada. So it's 100 factorial comparisons that need to happen in order to do the final, in order to have the final grouping or analysis done. So I have to do this 100 times. And I have to take that comparison, and I still need to decide what is considered a, Oh, somebody actually posted. What is the Streamerverse project? I'm sorry I missed that. I wasn't even looking at chat. I was kind of just talking to myself. If you're still here, the Streamerverse project is basically I'm creating a... Let's see if I can find it. Do I have it in my bookmarks? Control B, Control Shift B. I don't. Okay, but if you've seen Reddit stream comparison, stream viewer comparison. Again, I should just really save this image. This is basically it. Yeah, this is basically the original Streamerverse project, and I'm just trying to make this as a live version. So this guy, Kegrish, I have no idea how to say his name. Fuck. I should save this actually, just to make this very easy for myself. Bookmark this. I'm making a live version of basically this chart. That's the short and gist of it. I'm trying to make this chart as interactable and... Wait, is this new? This is 3 months ago. I'm hallucinating. 3 months ago. What is 3 months ago? December. Oh, this is the original one. Yeah, this is the original one. This isn't the one I remember. I think there's a better... I believe there's a better one. Hold on, let me try and find it. Streamer viewer relationship. No, streamer, not viewer relationship. Streamer viewer similarities. There it is. Control Shift B. Let's delete this. Ooh, don't. Ooh, stop that. What just happened? Okay, and available here. Okay, whatever. It's not really gonna let me, but as you can see here, he's got all the relationships going, and I'm trying to make a live version of that. Sorry I missed that comment from the chat, the one guy in chat, but hey, that's how it is. I kind of get tunnel vision really quickly. But it looks like don't know what else. I can move this into its own function. I still have to do this analysis. I'm just wondering what defines a strongly typed relationship. How, I should bring this back up. How the original author, Kieran Gregan, I'm not going to try and pronounce that last night, but how Kieran did this is he defined strongly typed as having 300 or more viewers in common. If you had 300 or more viewers in common, you had a line drawn between you. If you had... And the larger over 300 you went, the stronger that line was. So like if I were to go to the higher res version, you can see here like open image in new tab. You can see here this strong line between wind strike and blast, like this really thick line that signifies that they had a really strong connection in viewership over the week period. Or like, oh, I guess this is actually a way better example. Look at Tommy and Tubbo. Look how thick that line is. Look how big that boy is. That is insane to think how many viewers are shared between these two Minecraft streamers. And and the original author, Kieran, just said 300 or more, and that's a line. And I don't think he's wrong. He's definitely not wrong in saying that. It's just that I think there's a better way of comparing the similarities in streamers. And I think the best way to do that isn't based on how many viewers you see at one point are the same, but how often those same viewers appear in the other chat. Because you may be in the other person's chat as a one-off, just checking them out, but never again ever show up in that chat. And to say that those viewers are shared, I think is not entirely true, because let's say viewer A from Tubbo is checking out, or let's say Tommy, because he's the bigger one. No disrespect to Tubbo, but Tommy, viewer A, wants to check out Tubbo because they play a lot together. So one day, viewer A goes into Tubbo's stream, and on that particular day, I ran my code to find out who's I find out who's in Tubbo's chat. I see viewer A, and I say, oh wait, I've seen viewer A billions of times in Tommy's, so that means he shares this viewer. But then viewer A never again shows up in Tubbo's stream. That's just not right. If he never shows up in Tubbo's stream again, I can't really say that they share that viewer. It's just that viewer A just didn't like Tubbo as a okay, that sounded really bad. I didn't mean it like that, but he just didn't like Tubbo's stream. He prefers Tommy's stream. So that's how he defined it, and I think it's better to signify how often you see them. The problem with doing that, though, is that's more metrics you need to track and a lot harder to keep organized. Like, here we are, yeah, so Chinese and finally extremely like Game Awards. Yeah, so an overlap, each streamer writing an overlap above 300 into a large dictionary. So you can see here, he queried the top 100 streamers, similar to what I'm doing, added them to a database, removing duplicate viewers to add up with a massive list of streamers and unique viewers. He did it that way. I see what he's doing. That's not bad, but you can compress that data down because you don't need to keep each of the individual viewers. You could ad hoc or on demand compare the streamers and just save the comparison. That would be smaller, and you wouldn't have to use a gigabyte of data in that case if you did it. An overlap between the viewers each streamer writing above any overlap above 300. So if at any given point there was an overlap of 300, he added that into a large dictionary, was processed and imported into the graphing library. So he did this combinational factorial comparison and found that of the 100 streamers, this is their relationship. And it's a very beautiful graph. I have to give him huge props to how he laid this graph out. It looks amazing, and I do really want to replicate the way it's designed, but that would be really hard in a live format, I think, so I might have to compromise here. I'm getting off topic, though. I should be focusing on the parallelization. So I've been able to parallelize it, as you can see here. Simple calls, 10 workers doing streams, doing 100, doing however many jobs they can. Like, how many times does worker 10 come up? 20 times. So that means worker 10, bless his soul, processed 10 streamers. He even processed Shroud, as you can see there. Worker 1 did 10, 2 did 10, 3 did 10. Oh, 5, the lazy piece of shit, only did 7. That means somewhere along the line, one of the other workers picked up his slack. And even 6, slightly slacking, only went through 9 streams. 7, look at this lazy ass, only 6. 8 was lazy. Oh, and there you go. There's your overworker. 9 went through 12. Yeah. So basically, wait a minute. That doesn't add up. 10, 20, 30, 40, 47, 46, no, 56, 62, 69, 71, 81, 91. What? No. Did it miss? Oh, I know. Worker 0. Can't forget about Worker 0 pulling in those last 9 to pull out to 100. Okay, no, I wasn't missing somebody. Thank God. I thought for a second there I just completely fucked it and messed up the parallelization, but no, I forgot Worker 0 because this starts from 0, not from 1. Because that's how it works in programming. It's 0 denoted, or 0 delimited, or whatever you want to say. The delimited is the wrong word, though, for sure. Okay, so it looks like I've done what I think I can do for now. I'm at an hour, and I'm trying to keep the stream shorter than usual, so I think I'll stop for now. Next time, I'll get into like the analyzing part and maybe more cleanup. But as you can see here, and this is kind of yucky having these as global variables. Yucky, one of my 5. I prefer to have them maybe as kind of as things I pass around, maybe defined down here. I don't know. In any case, I have to do this comparison how many times again? 9 to the 157. I don't know what that would be delimited. I don't know how many zeros that is. I don't know how many what a googleplex is. What's over a trillion, quadrillion, quintillion, sextillion? How many zeros? How many zeros in a what's gazillion? Gazillion? Nope, gazillion's way too big. Quintillion? 18 zeros. No. So quintillion, which is 5, is 18. Quadrillion is 15 zeros. So it's add 3. It's 3 times 4, which is... No, so it's... Quad is 4. So there's billion, trillion, quadrillion, quintillion. So 4 times, what is that, 15? No, 4 times 3 is 12, added another 3. So x multiplied by 3 plus 3? What's quintillion? Quintillion is 18, so 5 multiplied by 3, it's... Oh, yeah, that works, yeah. So what's 157? Minus 3, that's 100, whatever the denotion of 155 is. Oh my god. I don't know. Divide 155 by 3. What's 155 divided by 3? That's 51. Wait, no, sorry. 54 divided by 3. Wait. What am I smoking? Hold on. 157, yeah. So it'd be 154, let's say 51. So it's 51 multiplied by 3 plus 3 would give you all roughly in that ballpark. How many it would be? Yeah, that's how it would be. So it'd be roughly 156 zeros, give or take, or give a lot more actually. Oh god, that's a lot of things to compare. Oh god. I'm probably gonna have to parallelize that comparison. How would I do that though? How would I parallelize the parallelize? Oh god, I paralyzed just getting all the data. Now I'm gonna parallelize comparing the data. How would I compare the data in a parallel stream? Each streamer, 100 streamers? No, I'd probably want to batch it again, do 10. Probably want to do 10. And then every worker has 10 jobs to complete where they analyze 10 streamers to 100 streamers. So they're given 10 streamers to compare to the list of 100 streamers. But how would I make sure that they don't overlap in comparison? Oh god, this is gonna be difficult. I'm just thinking about this now. I'd have to handle a lot of crap to get this to work properly. Okay, but for now, I'm stalling again as I usually do. I'll stop. Oh. Alright, as you saw there, that's parallelization. I didn't think this would take as long as it did, and I'm not really done, to be honest. There's a lot more that I need to do, but hey, it's getting there. If you stopped by, thanks for stopping by. I did see a comment in chat, which I'm really sorry I missed that. I was just pigeonholing myself, and usually what happens is I don't keep track of this sort of stuff, because I don't expect it to happen. So, hey, if I can, if I can make a, if I can, if you want, make a comment on the VOD if you have any questions, or if you want me to answer some programming related stuff. I'm happy to do that. I don't mind it. If you want to know more about the Streamerverse project, hey, I'm happy to explain it too. But I really appreciate anybody who stops by to watch this sort of stuff. I'm just doing this as a hobby, and seeing some feedback from my hobby is still fun to see. But for now, that this is the last stream of the week. I'll be taking a break until Friday again, and next Friday we'll be finishing up the Halo Combat Evolved playthrough on Saturday and Sunday, playing the last 2 missions. Friday, more programming, which will probably be the parallelization of the analysis. So I'm going to be doing more parallelizing, but this time parallelizing then just the analysis part. Maybe starting out without parallelization on the analysis, just to get that down, and then adding the parallelization on top of that. I think that's probably what I'll do, because it seems like that'd be the best way forward. But for now, I'll just have to think about this in the back for the next week, because there's going to be a lot of technicalities around what is considered a connection for streamers, and what is the best way to parallelize this without having to overcomplicate the matter. Alright, but thanks a lot for checking in, and hope you had learned something, or hope you enjoyed your time if you didn't come here for learning, just for entertainment purposes. I'll see you guys next week.